4 annual cash flows of $6,000 each, starting 4 years from today. All right, we're going to be careful with this. We have 4 annual cash flows of $6,000 each. That's an annuity. Okay, we have equal cash flows, equal intervals. So we can treat this as an annuity instead of individual single cash flows. Starting 4 years from today. Okay, so here's the twist. This is a deferred annuity. Right? This is not like our standard annuities where the first cash flow is in 1 year from today. These are starting 4 years from today. So we're going to have to be careful about the timeline, and we're going to have to be careful about the way we use our formulas, because our annuity formulas are derived for the simple case of regular annuity where the first cash flow is in 1 year. So we have to be careful. So our first step should be drawing the timeline and doing it carefully. Here we have 0, year 1, nothing. This is deferred, right? Normally, if we had a regular annuity, we would have the 6,000 right away here, but we don't. Year 2, 3 years from today, and then 4 years from today. All right, so now we have action, right? Starting 4 years from today, our first of 4 cash flows, 6,000, okay? So now 1 more year, 1 more cash flow. Now what you need to be careful, a common mistake, is to not draw a timeline and then to think, all right, I will have 6,000, 6,000, 6,000, 6,000, easy. You know, when is this gonna end? When is the last cash flow? Oh, 4 years from today, there are 4 plus 4, 8, year 8, last cash flow. And that is not correct. You have to be careful. That's where it can be a little bit misleading, and that's why drawing a timeline is very important. So year 1, or cash flow 1 is at year 4, cash flow 2 is at year 5, cash flow 3 is at year 6, and cash flow 4, the last one, is at year 7. Okay, not 8, 7. You have to be careful when you have deferred annuities where they end. So 4, 5, 6, 7, there are 4 cash flows ending at year 7. And you will see that this will end up being very important in a little bit. All right, so that's our setup. By the way, we of course need an interest rate. We need an I, right? So let's say 8%. So this is more like maybe stock market return. So think of it as I will put $6,000 each year for 4 years in the stock market, and I expect, historically say, my expectation is that I will earn 8% return on these investments, 8% per year, something like that. Okay. So now, what are we looking for? There are 2 possibilities. We can look for the future value of this deferred annuity. So for example, how much are we going to have as a result of our savings or investments or deposits earning this much? These are our deposits. How much are we going to have at the end? Well, at the end when? An easy one is, say, at the end of year 7. So the last time, the point where we put the last $6,000, how much are we going to have in the account? Or it could be a future period. So we stop putting in money at this point, but then we let it grow, right? So it continues to earn 8% for however many more years. And then we can ask, okay, how much are we going to have at that point? All right, so let's start with this. How much are we going to have at the time when we make the last deposit, right, into the account? And this is fairly easy because that's exactly what our annuity formula, future value of annuity formula is derived for, right? So let's remember, what is this basic setup for our annuity formulas? So you need to sort of burn that in your brain because we're going to apply it to more complex situations. So you need to know exactly how that works. So remember this. Our standard setup is we have n cash flows, right? And this is not deferred. This is pretty standard setup. I is our interest rate. And our future value of annuity formula is derived to give us the future value of these cash flows, so they are earning compound interest, as of exactly the last cash flow. Okay, that's what our future value of annuity formula is derived for. So that's what it gives. Not one period before, not one period after, exactly when the last cash flow is. And our present value of annuity formula is derived to give us the discounted value at I, this is our discount rate, the discounted value of these future cash flows. Be careful, not necessarily as of year 0, at point 0 today. It works, that works in this setup. But actually the rule is we get the discounted value as of exactly one period before the first cash flow. That's the setup, right? This is what our formulas are derived for, and that's what they give us. Future value as of last cash flow, present value as of one period before the first cash flow. Okay, so with this in mind, let's go back to that. Okay, we're going to use the future value of annuity formula, and we're keeping in mind that it will give us the accumulated amount as of the last cash flow, as of 7. Okay, and later on we're going to do discounting. We're going to come back and remember, when we apply the PV annuity formula, it is not going to directly give us the discounted value of these at 0. Right? It is going to give us the discounted value of these as of one period before the first 6,000, so as of 3. Okay, then if you need to go back to 0, which we usually do, we're going to have to do some additional work to bring it. So that's the trick, that's the twist with deferred annuities, is you got to know when the last cash flow is, because that's what the future value of annuity formula will give you. And you need to know, you need to remember that when you plug things in the PV annuity formula, you're going to get the discounted value as of one period before the first cash flow, not 0. So the PV terminology is misleading, right? It's not always present value. It depends where cash flows start, one period before.